Today I'm going to teach you how car alternators work. Well, it's pretty much how all alternators work, so be prepared. There's electrical theory, but I'll try to make it as practical as possible so anybody can understand. I disassembled an ordinary Nippon Deso Japanese car alternator, but they all work the same. So you have four major components: the back housing, the front housing, the armature, and the stator coil, and diodes, and a voltage regulator. So let's talk about the armature first. It's the part that gets spun because it's attached to the pulley. The belt turns. All it is a DC electromagnet. These are like north and south poles made of steel, like so. 12 volts more or less comes into the commutators through the brushes, just goes to a coil of wire, one single coil, and they energize these metal cores and turn them into electromagnets. North south, constantly spinning around. And on the end is just a bearing. And of course there's one in this end too. And some little cooling fins. Now on your stator coil, looks like there's a whole bunch of different coils. But there's actually only 3 coils in here. And they're all connected together in the middle. And they have 3 outputs. This one happens to be burned out. Very common problem in alternators. And the coils have turned black. They're supposed to be gold in most cases, or green. And if you look inside, you can see many little steel ribs. Those are called poles. Every time the north and south of these magnets rotates past one of these poles, it pushes electrons through the coils of wire. Now you can see the outputs of your stator winding coming out here, going to this metal plate and this metal plate. What they do is they attach to diodes. There's 6 diodes in an alternator, and this is the heat sink that holds a diode. That means it carries away the heat because diodes create a little bit of heat. There's one set attaches to this, 3 there. Another set of diodes attach here, 3 there. This plate is grounded, and this plate is to the positive output of the alternator. And this is the bolt that the big red wire would attach to for the positive output. Of course, the ground just works through the body of the alternator because these 3 other screws just attach to these other holes. Now, an alternator always has another connector on it with 1 to 4 other terminals. One of the terminals is called the exciter terminal. So that's when you turn your ignition on in your car. It sends 12 volts to the regulator of the alternator, which then sends some power to the coil in the alternator, and that causes excitement voltage to start producing electromagnetism so the alternator can start to function. Just spinning an alternator with giving it no little boost of electricity at first, it won't produce any electricity, but once you start it spinning, add a little shot of electricity, it'll keep producing its own after that. And the other wire, if it has a 2-pin terminal like this one, goes to your lamp on your dashboard. You know, the colored lamp that turns orange or red that tells you when your system is not functioning or putting out the correct voltage. You know, defective alternator or broken belt. Many of the General Motors alternators of years gone by actually had to have a functioning light bulb in the circuit for your idiot light. If that light bulb was removed or burned out, your alternator didn't work, and you'd end up changing lots of alternators and wondered why it still didn't work. Now looking at this assembly from the back view, which would be in there on the alternator, that's the voltage regulator. That's that connector that I just showed you. That's the B+ positive output. And these are your brushes, which go on your commutator. They're spring-loaded. There's a little hole there, so when you want to reassemble alternator, you push them all the way in and drop a little pin down that hole, which coincides with that hole, and that holds them retracted so that this can slip into the pocket and not break off the brushes. When everything's assembled, you withdraw the pin, the brushes pop back out, and make connection on the commutator. The voltage regulator we're looking at now is a little circuit with some transistors in there that regulate how much electricity goes into the electromagnet on your armature through the commutator, and that's how it controls the voltage output. If it wants more voltage output, it adds more voltage here, then it becomes a more powerful electromagnet. And that pushes more electrons through here. Now for the technical part. I'll show you a schematic diagram of actually what's going on inside an alternator and how it works. So there it is. Just from memory of years gone by, I redrew the schematic diagram of how a typical car alternator works. This coil here on the stator is these three different coils here, and they're all connected together at one point, have three outputs. Each one produces AC voltage. On the armature, that represents this coil. It's a single coil of wire with the soft iron core represented in the straight lines. I didn't draw that in here, but to make this drawing more accurate, if I would have drawn it in, it would be better, because that would represent this iron core. The outputs of these three coils all go each to a pair of diodes. Diodes are reversed. One set of diodes goes to ground on their output, and the other set of diodes goes to your positive terminal for your output. So that equals that big terminal in the back of your alternator. And these three schematic ground diagrams equal these 3 bolts. Those 6 diodes, well, you can't really see them, but they're in between these plates. The voltage regulator, there's the voltage regulator. One wire is the exciter on that terminal. The other wire goes to the idiot lamp. Has an output that sends power through the brushes to energize the armature. And there's another brush for the other part of the commutator, which goes to ground. This circuit of diodes, with the way one is reversed, you know, they're back and forth, it's called a full wave rectifier circuit. How a diode works is the power that goes through them can flow against the arrowhead. That means the power is flowing in this direction. A diode is a one-way valve. It can only allow electricity to flow through in one direction. So if it's set for a direction to allow positive to flow through, it will only allow positive. You can put all the negative to it and it won't flow through. Vice versa, if you turn the diode around, you can allow negative to flow through, but not positive. So AC voltage is a sine curve. It's going negative and positive all the time. So it's both polarities. The diodes act as a one-way filter valve. This one allowing negative to pass through, this one allowing positive to pass through, and so on for each winding. On this rotating armature, it just uses plain old DC, so there's positive coming in one end, so it just stays constantly electrified and magnetic. So this part would actually be spinning like this. So how this circuit works is, there's 3 different coils, each producing a positive and a negative voltage. The center line is 0 volts. This peak is plus 6 volts. This lower peak is minus 6 volts. Now there's 3 different coils, and each one's producing the same. They're all attached at one end, but they're out of phase. So I drew light little lines so you can see what I mean. When this one's peaking at a different time. It's off center. And when this one's functioning, it's actually opposite to this one. So that each one's 1/3 out of phase to the other one. Now because the 3 peaks all don't line up, the effective output of that alternator is called a ripple circuit. Little bumps of plus 6 volts, little bumps of minus 6 volts. And that all goes through the 6 diodes to be turned into DC. Now with an alternator, it makes no difference which way it's spinning to produce voltage. It produces exactly the same kind of AC voltage in either direction as efficiently one way or the other way. There's also no limit to the amount of voltage one can put out. It just depends how fast you spin it. So a 12-volt alternator technically can be turned into a 120-volt alternator for use in a wind generator or something like that if you create your own voltage regulator, or buy one from someplace that is set to regulate it for 120 volts. But for example, if your alternator was a 100 amp output alternator, which is very common for cars, that would be 100 amps at 12 volts. But if you turned it into a wind generator alternator that produced 120 volts, then its effective output would only be 10 amps. You can't change the wattage of your alternator. If it's a 500 watt alternator, it's always going to be a 500 watt alternator, because watts is amps times volts. So when this is spinning, that's this. It's powered up with DC voltage, turning that into an electromagnet with many north and south poles. So that is spinning like this. That is spinning in the middle of these three coils, and that's pushing electrons out. AC voltage. Each AC voltage is both positive and negative. So the two polarities are separated, this one becoming negative and going to ground or earth on each one, the other one becoming positive and going to the positive output. To regulate the voltage, some positive power goes through the voltage regulator, and it tells it how much to send to your armature, and it goes through two brushes. Then there's the lamp, which is off when your vehicle is running and it's putting out the correct voltage. And when your ignition is turned on, the exciter wire coming in gives it the initial kick voltage so it can all start working. And the negative output, of course, is just coming off the ground with the body of the alternator. Now on large alternators, like a wind generator or something like that, you can have as many, coils of induction. You can have as many coils as you want on your stator. You don't just have to have 3, you could have 20. It's just that on a car alternator there isn't enough room to put more than 3. But on a very large diameter wind generator alternator or something like that, you could have as many as you want. That makes a less ripply output and a more efficient alternator. So, most common problems with alternators. Burned out windings, number 1. They least often burn out here. Next is worn out brushes, the simplest thing to fix of all. Next is bad voltage regulator. And last is shorted diodes. They very rarely blow to an open circuit. They usually blow to shorted and allow some AC voltage to mix with the DC output. And this makes it a less efficient alternator. So if you have an alternator that is maybe putting out between 12 and 13 volts, it may have a bad voltage regulator or a bad diode. If it's putting out like over 14, it's probably a perfect alternator. So in my eyes, how an alternator works is actually very simple. They even look simple when you take them apart. So if you ever want to repair one, don't be afraid. You might need a voltage regulator, diodes, brushes, or a stator coil. No big deal.